All right, we're going to be doing Algebra 1, 3.3.3, which is graphs of functions. I have the checkup problem like we've been using right here inside the thing, so hopefully I'll be able to edit it as we go on here. All right, question number 1. What is the domain and range? Well, let's remind ourselves what domain and range is first. Remember, domain is the set of all independent variables or all x values. Range is all the dependent variables or all the y values. So if I'm looking at this first question, all right, I want to go x value. So I'm like, all right, how far left and right does this go? So I'm going to draw, all right, it goes here and all the way down, and then like here and all the way down, right? So there's all the x's, right? So it goes from -3 to 3. It's not perfectly written, but -3 to 3, right? So that's what my domain is, right? Wrong, not right. All right. Because this graph goes up to the edge of my frame, all right, do you see how this goes all the way up to the edge of it and then it stops? We have to assume when that happens that this graph is going to be continuing on forever. All right, it goes to the edge of the frame and there's nothing that we can see that will stop it. Right, it just goes right up to the edge of the frame, so we're going to assume that it goes on forever. Obviously, we don't have infinite space on our practice sheet, so we can't put a full, very, very super large graph that goes up into the millions. But when they put it all the way up to the edge, it means it's going on forever. And if we look at the vertex, right, from here, notice how it's expanding left, and it keeps expanding out and keeps expanding out. If we had infinite space and infinite time, we would see that this graph continues to expand out forever and ever and ever and ever and ever and ever and ever all the way up, right? It would just continue to slowly but surely just expand out and 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 out. And this side would do the same thing. It would expand out and out and out and out and out. And obviously that's not a great graph, but over the course of infinite time and infinite space, these would continue to go out forever and ever. There's nothing stopping this graph from going left or right. So when there's nothing stopping us from going left or right, we can say our domain is all real numbers. So my domain is all real numbers. There's nothing stopping this graph from going to negative infinity to the left or positive infinity to the right. Now if I do range, is there any point now low, like so it stops here? If I draw my line here, all right, that's the lowest it goes. It never goes beyond it. It didn't go to the edge of my frame on the bottom. It stopped there. And now it goes up again to the edge of the frame. So we're going to assume again it goes up forever and ever. But it didn't go down forever and ever. All right, so it's at 0 here. And it goes up. It doesn't go less than 0. So my range would be y is greater than or equal to 0. All right, because I have a floor right there at 0, but then it goes up towards positive infinity forever. And yes, I get it's kind of goofy, but I think you'll learn to like it. And by like it, I mean tolerate it just enough to get the quiz done and get your summer school credit. You'll be all right. Now let's do domains. We're looking at x's and y's. So I can see that this graph kind of stops there. So I'm going to take and draw my line right. Oh, that's a bad line. Right? And this graph stops going left right there. It doesn't stop at the edge of the frame. It stops right there in the middle. So I can okay and put a line there. And then going to the right, because domain is left and right, it's my x values. Going to the right, this graph meets the edge. All right. And we have to assume, because it goes to the edge and we see nothing that would stop it, that it will go on forever and ever. So my domain for this problem is going to be x, right? Because made my x values is going to be greater than or equal to 0. All right, because it kind of stops right there at 0, and it keeps going right forever. So that's x is greater than or equal to 0. if I go ahead and start talking about my y's, which is up and down, well, again, this graph stops here. It doesn't go any further down than right here. So I'm going to draw this little floor next to it, right? Because it doesn't go beyond that floor in the green line I just drew. And then, like we discussed with the domain, this graph is continuing to go, and it goes to the edge, and there's nothing that's going to stop it. And if we see from where it started here to where it's finishing, it's continuing to increase. It's obviously not increasing rapidly. It's going to take it a long time. But if we had infinite time and infinite space, this graph would continue to grow both up and to the right. It would go towards positive infinity of the y's and positive infinity of the x's. So with this information, I can say that my range is going to be y is greater than or equal to 0. Stops at 0, and it keeps going up forever. There's nothing stopping it. Oh, sorry, I can't move that. Questions 3 and 4. Classify each graph as increasing, decreasing, or constant. Well, we read everything like we read a book, and we read a book from left to right. So when we read a book from left to right, it's from here to there. All right, and as I go from, and I guess that's kind of an ugly one. And as I go from left to right, what is this red line doing? Well, it is increasing. It's going up. So as I go from left to right, the red line is continuing to go up. So this is an increasing graph. Now doing the same thing over here for number 4. I'm going to draw my little arrow from left to right. As I go from left to right, my red line is going down. I go from left to right, my red line is going down. Well, that means it is decreasing. So I read this just like I read a book from left to right. All right. Now, what would constant look like? Well, this green line I have here on number 3, and I guess on number 4. Number 4 is just not as neat. This is a straight line that's not going up or down. It's just going across. That would be constant, right? It's just a flat line, flat horizontal line. It's not going up. It's not going down. It's just constant. All right. Let's go to the next. Questions 5 through 8, use the graph to answer the questions. All right, so we have this little graph here. Where is this graph increasing, right? And increasing means it's going up from left to right. Where are we going up from left to right? Well, here, this would be considered going up. And if we're asking this, they're asking for the x values. So this graph is increasing from x equals 0 to x equals 2. So it's increasing from here to there. Now I'm not going to say this is increasing from -6 to -3 because those are my y values. I'm looking at this from the x values. This graph is increasing from the x value of 0 to the x value of 2. Now they're asking, where is this graph decreasing? Well, I would say this is decreasing at a couple spots. Now, right next to, oh, I apologize. I had a little sound get buzzed into me. Oh, excuse me. So, where's the graph decreasing? Well, let me change my color here. Well, it just increased here. I'm also going to say it is decreasing right there. So it's decreasing from x equals 2 to x equals 4. So it's decreasing in between this range from 2 to 4 of my x values. Again, I'm not going to say -3 to -6. I'm going to say my x value of 2 to my x value of 4 is where I'm decreasing. Now, I would make the argument that is also decreasing here and here. So it's actually decreasing at x equals -3 and x equals -6, I think. But I don't think you're going to get that question on the quiz. When I reviewed the quizzes and the test, I don't believe there's going to be a question that looks like this necessarily. But technically, those are going down. and we probably could count them as decreasing. Next question is, where is the graph constant? Remember, constant is that horizontal line. So I would say it's constant here, here, and here. So from here to there, so from -6 to -3, from -3 to 0, and from 4 to 7. Oh. So it's it's constant, excuse me, from here to here, -6 to -3, from here to here, which is -3 to 0, and then from here to here, 4 to 7, right? The constant is just when it's flat. And then identify an intercept. All right, so an intercept is anywhere the graph crosses the x-axis or the y-axis. All right, so what I see is a right there. Oh, I guess I can't see it too well. It looks to me like it's crossing at 0, -6. All right, so it crosses the y-axis at -6. All right, so when they're talking about an intercept, they're talking about where it crosses either the x-axis, which is right there, or the y-axis, which is right there. So anywhere it crosses the x-axis or the y-axis, it would be called an intercept. So for this graph, identify a single intercept. It crosses the y-axis at 0, -6. Use the graph to answer the following questions. All right, so identify the relationship between the variables. What is a function of what? Well, the weight of the apples in pounds is on the x-axis, and then the cost is on the y-axis. So what we'll say is that the cost is a function of the weight, because the cost is dependent upon the weight. All right, we cannot determine the cost until we determine the weight. So cost is a function of weight. All right, so the dependent variable will go in this scenario, and then after the function of, that's where the independent variable goes. Now, when the weight of apples is 5 pounds, the cost is, well, if I go here to 5 pounds, draw this up, well, that means the cost is over here. So that's going to be $6. This is associated with the point on the graph 5, 6. Right there is 5, 6. When the weight is 10 pounds, the cost is, well, if I go up here again, so 10, bring it over, that's now going to be 11, 12. It's $12. And that's associated with the point, well, 10, 12, right? Because weight is my x value and cost is my y value. That looks like a B. All right, so what we covered, let's go a quick review here, is for domain and range, I'm just looking to see where, if the graph is going to continue on forever. If I'm talking about domain, I'm only looking at the left and the right. I'm not worried about where it goes up and down, anything like that. I just want to know if it continues to go, continues to grow, will it keep going left and right? The range is up and down. It's the y value. So I'm looking, is it going to go up and down anymore? Increasing, like a book, I'm reading left to right. So if I go left to right and the graph goes up, it's increasing. If I go left to right and the graph goes down, it's decreasing. If I go left to right and the graph stays horizontal, it doesn't go up or down, that's constant. And then when we're looking for where's the graph increasing, where's the graph decreasing, where's the graph constant, we're just looking at the x values, not the y values, the x values of where the graph is either going up, going down, or staying the same. And then an intercept is anywhere the graph crosses the x or y axis. And then again, the dependent variable will always go first, is a function of, and then that would be where the independent variable goes. The weight of the apples was 5 pounds, so that was on the x-axis. I found the 5 and I just kind of went up to the graph, and I went over to the y-axis, and that gave me my cost, and then I got my ordered pair the same way.